Hey Chem students, welcome back to your next lecture video for chapter 1, picking up here on slide number 6. So we just talked about the definition for pure substances, and what I'm doing here with these blanks that are on the screen instead of words to fill into your blanks and your notes is I'm asking a review question. Notice this little symbol here at the front of the line, that little backwards swirling arrow. Whenever you see that pop up, this is going to be a review question, something we've gone over specifically, or something that I just think is in your background of science knowledge. If it's not, I'll update that for future years, but that's what these are. They are review questions. So look back at your definition for pure substances and fill in those blanks. So the next type of pure substance is a compound. And what compounds are, they contain more than one element chemically bonded together. For compounds, that term from the pure substance definition, that term fixed composition, means that each unique compound always contains the same element in the same ratio. If the elements or the ratio of elements within a compound is changed, then the compound's name must be changed, and so will its properties. So that change can come from like an actual chemical reaction where the atoms are ripped apart and then rearranged to form and make new compounds with new names and new properties, or just from a new learner writing down a formula wrong. We can't think that if we get the formula wrong that the name or the compound we're talking about is still the same. Okay, the names and the formulas are very specific to each other and they go together. And just to give you a small few examples of what I mean by that, we're going to look at some examples of different compounds that hydrogen, oxygen, and carbon combine to form. So let's start with a simple one. 2 hydrogen atoms and 1 oxygen atom, well, they form H2O, and we call that water. And we know that that is a life-giving liquid. It's a substance we need for life as we know it. But if that formula changes just a little bit, let's say you were in a hurry, you were writing down H2O, but you wrote down H2O2, we can't assume that that's water anymore because that's a different formula. That's hydrogen peroxide, which is a totally different substance. We use it actually to clean out cuts and wounds and things like that because it's really good at kind of breaking down simple-celled organisms and really ending the life that's in them. So it's very different from water itself. Change it just a little bit more, 2 oxygen atoms still, but 1 carbon atom. And now we're talking about a gas that, well, it's not one you want in your body for long, but it does exist in your body. It's a part of our metabolic processes. It's what we exhale every time we breathe. But if we can't exhale, if we can't get it out, then it's not gonna help us. It's gonna be harmful to our life. Carbon monoxide, just another little difference there, is another gas, but it's even more dangerous and it's not common in your body. This one comes from any type of what am I trying to say? Any type of combustion of like organic fuel, like a wood fireplace, a gas stove, an engine exhaust. And if you have any type of that in your home, like a wood fireplace or a wood burning stove or any kind of gas lines, you need to have a carbon monoxide detector in your home because this is actually a pretty poisonous gas, and it's odorless sometimes if you don't have the smoke and fumes that come along with like the fuel that's used. The carbon monoxide itself is odorless, and that's where carbon monoxide detectors can be life-saving in the home. Change it a little bit more, and we still have a gas, but CH3 is methane. This is a fuel in and of itself. And I hope you see through these 5 different compounds with just little changes from one formula to the next that we can illustrate and understand this point. Even small changes in chemistry can have big effects. And I make this point early on in the year just to help you understand the respect you need to have for the study of chemistry, for the details in it, but also for when we're doing lab. You're always going to be given like a procedure, a step-by-step set of instructions, and you're going to be given those to keep you safe in your exploration of the activity. And if you change those, if you go off script, if you change the plans without letting me know, you could really be putting yourself and the others around you at really big risk because, like we said here, even small changes in chemistry can have big effects. So continuing with compounds, the next idea I want you to kind of absorb is that properties of compounds are usually very different from the properties of the elements within it. So here we have 3 pictures. We have a grayish solid thing that's being cut with a knife. The person cutting is holding it with a glove. They're not wanting to touch it with their hand. Then we have a Erlenmeyer flask here with a stopper on it holding in like a yellowish gas that's in there. And then you see the red arrow and the red plus sign and the arrow. It's showing that if the first two things combine, we get this third thing, which is a kind of a clear, translucent crystal shaped thing. Now, if you look at these little models, we can see that all of the pieces of this first substance are the same. All of the pieces of the second substance are the same, but this third substance is a combination of the first two. So that tells us that this first thing is an element, the next thing is an element, but the third thing is a compound. And with a little bit more discussion that we had in class, we found out that this is a sodium metal, chlorine gas, and sodium chloride, or table salt. Now let's think about what we're seeing here. We're seeing a gray solid metal that can combine with a yellow gas, and it forms a clear crystal. So just on like a visual level, we can see that this point I'm making here on the slide, that the properties of compounds are usually very different from the properties of elements within it. That's true even on a visual level. But if we think about the properties, the chemical properties, the behavior of these substances a little more, it gets even weirder. Sodium metal is super reactive with water. It is very explosive when it reacts with water, which is why the person handling it in this picture is wearing a glove so the moisture of their skin does not react with the metal. Chlorine gas is very toxic. It is not safe at all to be around. You might think, wait, I might clean pools with that. You do clean pools with a chlorine compound, but it's not the pure chlorine gas that's here. But still, I mean, you're using it to clean a pool. Chlorine in itself is kind of an antibacterial, antiseptic kind of substance. It's not good for things that want to keep on living. And then you have this, which is table salt. This is a little tasty morsel that we put on all sorts of foods, and we eat it, and it's good, and it's actually necessary for our bodies. So let's think this through. If you put a sliver of this substance in your mouth with a bunch of water that's in there naturally, that would be explosive. That would be super dangerous. If this were to get into your body, that would be super deadly. But this is something that's necessary to have in your body. You need salt for your body to function. Now, yeah, the American diet does probably have more salt than you need, but it still is necessary. So on a visual level and then on a chemical properties level, we can see that these three substances illustrate this point really well. Sodium chloride, being a clear crystal and necessary in your body, is made up of two things that don't look anything like it and are really deadly to your body, very dangerous to your body. And yet, that's the truth. That's where it comes from. That's where it can be produced, through this method of combining sodium and chlorine to make sodium chloride. The next part about matter that we need to look at is mixtures. Now, mixtures are kind of like compounds because they are the combination of substances, but in a mixture, the substances are combined in such a way where each retains its chemical identity. Then there are two types of mixtures, heterogeneous versus homogeneous. Homogeneous means uniform, and their different substances are blended consistently throughout. We usually talk about two different very useful types of homogeneous mixtures, alloys, which are a combination of two or more metals. We make these so that the properties have the substances have superior properties to the pure metals. We use them in all sorts of different ways. Then, continuing that, solutions. Solutions are made by dissolving something into something else, and we call those two things solutes and solvents. The solute is always what is dissolved into the solvent. An example is like sweet tea, which is the whole solution. It's made by dissolving tea, a solute, and sugar, a solute, into water, which is the solvent. Solvents, the major part of solutions, are almost always liquids. Solutes, the minor part of solutions, can be solids, liquids, or gases. An example of a gas is carbonated drinks are a solution of carbon dioxide gas dissolved in water. And then two liquids dissolved together could be like rubbing alcohol, which is dissolved in water as we use it to clean our cuts and like disinfect our hands. Heterogeneous mixtures are non-uniform. Their different substances are not blended consistently throughout. Most things in nature fall into this category. An example is like a piece of granite. You can see this one rock or chunk of rock has a bunch of different pieces of other things that have been pushed together inside of it. And yet each of those things you can see clearly and individually. It's not one smooth blending piece of matter. And this question, I'm not really going to go over in the video. It's not urgent and specific to the things you need to learn for this chapter on the test, but it did present an interesting conversation in class that just wouldn't be effective to try to duplicate here in the video. And with that, we're going to stop the video here.